All right, so this time we're going to look at graphs where the original function is raised to some power, that power being a positive integer, and greater than 1, obviously, because raising it to the power of 1 would be, well, a little bit boring when you think about it. So again, we'd first draw the initial graph. Now this time, have a look at the derivative. If I differentiate function x to the power of n, we'd get n function x to the power of n minus 1 times f dash x. So what does that mean? That means all our original stationary points, so that'd be when f dash x is equal to 0, this new derivative is going to equal 0, but also where the original function was equal to 0, so x-intercepts, they now will become stationary points as well. So okay, here's our random curve. We'll do it squared. Let's do it squared first of all. The y values will change, of course, of the stationary point. So if I'm squaring a number bigger than 1, I know that's going to get bigger. This one here, you'll notice I changed the scale from the other one because -1 was at that point last time. But now I'm talking about a number that's smaller than 1. So when we square it, it will get smaller. But of course, negative numbers will all become positive as well. And so as I was saying, the x-intercepts will also become stationary points. So each one of those will become stationary points. And because this whole graph has to stay positive, we know they must end up being turning points rather than horizontal points of inflection. The vertical asymptote is going to stay the same because once again, if it was not in the domain of the original curve, it's not going to be in the domain of the new one. Horizontal one, well, horizontal asymptote, the original one, it's less than 1. So again, if I square a number less than 1, it's going to get smaller. So I've moved my horizontal asymptote down a bit. What's this one saying? Okay, if we're talking about the original curve has y values, and I'm not worried about the plus or minus, that's why I'm saying absolute value, is greater than 1, then the new curve must be above the original curve because the y value would get bigger. And if the original curve had a value smaller than 1, then the new curve will be below the original curve. So what that means is, all right, 1 is going to become a key point again because 1 to the power of anything, so in this case 1 squared, is going to stay at 1. But here, on the left-hand side, I know the new curve will be below the original curve. It'll then go through the point of intersection and go above the original curve once it's above 1. And I can do that for each of the sections. Of course, I have to reflect -1 up because that'll become +1. So where it was -1 is now +1. And there is our graph. So you can see it goes below the curve, equal to 1, above the curve. Bit hard to describe with the negative values because you're in the other one. But then once we get here, below, goes above, goes below, and so on. So, boop, there it is. There's function x all squared. Okay. So, squared, the one we just looked at. So if n is even, we know the curve's always going to be positive. But of course, if it was odd, then the sign will stay the same. So let's do the same curve, but this time we'll cube it instead of squaring it. Okay. So again, the stationary point, well, if I cube a number bigger than 1, it's going to be bigger than 1. Those x-intercepts will still be stationary points, but now these ones where it was an x-intercept before, it's still changing from positive to negative. We must have a horizontal point of inflection there rather than a turning point. There we go. Cube the asymptote, the horizontal one. Well, that's going to get smaller again. Vertical one will stay. What did I do on the next one? 1 cubed. 1 cubed is 1. -1 cubed is -1. And there it is. Some of my inflection points are a little bit dodgy, trying to draw it in there. But there we go. You see, as I'm trying to do a horizontal point of inflection as I go through those ones. So that would be function x cubed. And remember the only difference, as those powers get bigger, you'd be flatter at the base, steeper at the sides. I don't think I've ever seen a question which is bigger than the power of 3 on these ones. Okay, only 4. How generous is he today? Boy.